Steve, thank you very much for joining us here on 50/50. We've been hearing a lot about a combination of, harnessing wave and hydropower. How does that work?
Simon, this project is part of our overall research program, which is having a look into alternative ways of producing and storing electricity in South Africa. So this particular technology that we're looking at here is a variation of pump storage. Now, pump storage, you use off-peak electricity to pump water to the top of a mountain, and then when you need that electricity on peak, you take it down through the pumps, which now become turbines. So you have a dam at the top and a dam at the bottom. There's an established technology that's used using seawater. There's a plant that's been operating since the late 90s in Japan, which does the same, but it uses the sea and then a dam on the top of a cliff, essentially. What we want to look at is a variation of that, where you will have the dam on the top of a cliff, but you will use wave power to do the actual pumping. So the advantage of this technology then is that you'd be using a renewable energy source, which is your wave power, and combining it with a storage technology, which is then your dam at the top of the cliff.
And then I look at the sites that Eskom have proposed, and we've got a World Heritage Site, 2 national parks, 2 nature reserves, biodiversity areas, vulnerable ecosystems. I mean, I have some sympathy, but it seems every time Eskom looks at a part of our coastline, you blunder into all of these sort of sites.
What we are involved in at this stage is a very early assessment of sites. So all you look at now is that, have you got the sea and have you got a head? There's then a narrowing down process, and that's exactly why we're doing this. It's called a strategic environmental impact assessment. So it's not a full EIA, it's a strategic impact assessment that's really just looking at it from a macro perspective. We will narrow that down to from the current 17 sites to around about 5 sites. We will do a full environmental impact assessment on those 5 sites, and we will then factor that into our further design of the project and our decision making. And I must also emphasize is that this project is in the early stages of research. It may never happen, but we do have to consider the opportunities. For example, we've also looked at the possibility of tapping the Agulhas Current, which runs down the east coast of the country. And we've spent a lot of time and effort in characterizing that current to see whether then you can put turbines on the seabed, for example. We're not going to take that any further until the technology of turbines on the seabed is far advanced and well proven, and we're aware of what the impacts and the costs, et cetera, will be. But we've been through all of those studies. The same thing here with the wave power and the storage.
And so I suppose, similarly, the fact that a lot of this is on sandstone or granite geology in the Cape Mountains, which you know is highly fractured, very, very porous stuff. The last thing you want to do is be putting a saltwater dam on top of that.
Absolutely, absolutely. And that would probably exclude that site. And I think that the intention of a strategic impact assessment is just to say, look, we're having a look at this, give us any input. If it turns out that none of those sites are suitable, then it probably means that, well, that technology is not going to be suitable for implementation in South Africa. And I mean, part of that technology has, the wave portion of that technology has not been proven at scale at all. And so that's why it's part of our research activities.
Is the wave portion of it, is that a large facility that is environmentally, does it have a large environmental footprint? I mean, I've no real idea of what it would
could have. It depends. There's lots of different technologies that you can use to harness wave power. Any technology that you're using to produce energy or to transform energy will have an impact. What's important is that when you're starting to get familiar with these technologies, that you familiarize yourself with those impacts and make sure that you factor that then into assessing the technology for suitability and then possibly sometime in the future rolling out the technology.
All of the forecasts that I see have wave technology at around about 1% at the most of our national power grid ultimately.
Wave technology will not play a role in our energy mix up until around about 2030, unless you get a fundamental shift in the technology. I think that it's good practice for us to have a look at all of the primary energy sources that we have available in South Africa. I mean, we started doing work on solar energy 20 years ago when we were laughed at for saying that, well, you can actually, there's potential to operate a solar plant as a baseload plant. We're not that far away from that now.
So 50 years down the line, what do you think our power mix is going to look like?
That's an interesting one. 50 years down the line, I would love to see an energy plan for South Africa in 50 years that has got 100% renewables. I think that a lot of which would probably be a mixture of wind, solar with storage, ocean with storage, as well as probably a whole lot of small domestic suppliers and storage. That's probably what you'll have in 50 years' time with a smart grid. It's an exciting future.
Thanks very much for joining us, Steve.
Thank you, Simon.
Wel, dit bly tog interessant en miskien kan ons uiteindelik weg van steenkool aangedrewe kragstasies